thing I want you guys to be prepared for, so hopefully that made sense and you guys can kind of review problems like that. I believe we did one in class as well. Okay, so the next thing I want you guys to be aware of is derivatives of trig functions. So these are just equations we talked about. The derivative with respect to x of sine of x is cosine of x. The derivative with respect to x of cosine of x is negative sine of x. The derivative with respect to x of tangent of x is secant squared of x. And the derivative with respect to x of secant of x is tangent of x times secant of x. Okay, so you guys, I believe, have those on your cheat sheet. If you don't, I would write them down and have them next to you during the exam. Let's see here. I want you guys to remember that velocity is just the derivative of position, but that is instantaneous velocity. If you want to find average velocity, that's just the position, the first position minus the second position, or sorry, that's a lie. It's the second position minus the first position over the second time minus the first time. That's just change in position over change in time. We did a bunch of examples of this at the beginning of the year and also after exam 1. This was the first subject we talked about, so you guys should hopefully be familiar with this. My only other comment on that is that a good way to approximate instantaneous velocity is to take the average velocity of 2 points really close to each other, but that doesn't always work. If you're given a graph, just use your common sense as to whether or not something might represent the slope at a given point. For example, if I have a graph that looks like this, and it goes like this, let's say this is time and this is position, then my average velocity for this guy is to take this position and this time and average it out. Right, so let's say this is 5, this is 4, we'll say this is 0, and this is 2, let's say. So if I were to do my average velocity over the whole time, from t equals 0 to t equals 4, then that would be my second position, which is 5, minus my first position, which is 0. So 5 minus 0 is just 5, over my second time, which is 4, minus my first time, which is 0, so just 4. So that's 5/4. But if I were to tell you to say find my instantaneous velocity at 2, well, this average velocity wouldn't be very helpful, because if we look at 2, it looks like our velocity is near 0. The slope here is basically 0. So that's just something to keep in mind. If you wanted to find the average velocity right here, you need to take a smaller interval. What else? I want you guys to be comfortable with derivatives of e. So e to the x. Just a couple examples. We remember that the derivative of e to the x is just e to the x, but we need to be careful with the chain rule. So if I were to give you, for example, the derivative with respect to x of 6e to the 7x, I would get 6e to the 7x, because that's the derivative of like my outside equation. The derivative of e to the x is just e to the x. So the derivative of 6 e to the x would just be 6 e to the x. But now we have to deal with the 7x in here. And so I need to also take the derivative with respect to x of 7x. And so that would give me 6e to the 7x times 7, which would be 42e to the 7x. So just be careful with the chain rule. You guys should always be checking your chains. We talked about that a lot in class. Let's do another quick example. If we did the derivative with respect to x of 7 times 1 minus 2 e to the x to the 4th. This is a lot of chain rule information, so my outside function is this junk to the 4th, so I need to bring that 4 down to get 28. I leave the inside stuff, so I would get 1 minus 2 e to the x, and then I decrease my 4th power by 1, which gives me 3. And then I have 20, oops, sorry, we're not done. Then I need to do the derivative with respect to x of 1 minus 2 e to the x, because this part here is my chain. So I would get, if I rewrite 28 times 1 minus 2 e to the x to the 3rd, and then the derivative of this guy is the derivative of 1 minus the derivative of 2 e to the x. The derivative of 1 is just 0. And then the derivative of negative 2 e to the x is just negative 2 e to the x. So this overall, if I simplified it, would be negative 56 times e to the x minus 2 e to the 2x. Oh, I lied to you guys. You can't simplify it like that because there's a 3rd power. So actually the most simple way to do it would be 1 minus 2 e to the x to the 3rd e to the x. Okay. Yep. So that would be how you would do that one. Let's see, I have about 2 more things I need to cover. So implicit differentiation is something we went over. So that's where you have an equation that isn't solved for y, but you need to find the derivative of y with respect to x, and that's where you just assume that y is a function of x. We did a whole day and a half on this, I think, so if you guys go back in the notes, hopefully that's helpful. I also have it on my notes that I posted on WILE courses, but let's just do a really quick example. So I want you guys to find dy dx given x cubed plus y to the 1/2 equals 2. Okay, so I would need to first take the derivative of both sides. Which gives me 3x squared plus, now remember, we're thinking of y as a function of x, right? So this is actually y of x to the 1/2. So we're going to have to use the chain rule. Our outer function is to the 1/2, so we bring down our 1/2 power, leave the inside. I'm not going to write it as a function of x here, but just know that it is. And then decrease our power by 1, so we have a negative 1/2. And then we have to remember to multiply by the chain, which is just dy dx itself. And then the derivative of 2 with respect to x is just 0. And now all we have to do is solve for dy dx. So we'll get 1/2 y to the negative 1/2 dy dx is equal to negative 3x squared. And then I need to multiply by 1/2. I'll get y to the negative 1/2 dy dx is, or sorry, not multiply by negative 1/2. I need to multiply by 2 to get rid of the 1/2. And I get negative 6x squared. And then finally I need to divide by this y to the negative 1/2, which would be 1 over y to the negative 1/2, but 1 over y to the negative 1/2 is just y to the 1/2. That's just some power rule stuff. Power rule as in the algebra sense, not the calculus sense. Anyway, I would get negative 6x squared times y to the 1/2. Oh, and I forgot. Oh yeah, we're good. Okay. So that would be your answer. What else? I also want you guys to remember, here, what have I covered so far? Guys, we are cruising through this. For example, the derivative of the natural log. So let's do a natural log involving a chain rule just for practice. The derivative of the natural log of x is just 1 over x. So if I were to do d dx of the natural log of 2 sine to the third of x, then my outer function is the natural log, so I would have 1 over 2 sine cubed of x times the derivative with respect to x of 2 sine cubed of x, which is 1 over 2 sine cubed of x times, it's important to note here that this is actually 2 times sine of x quantity cubed, so this is another outer function, something to the third, times an inner function sine of x, or with an inner function sine of x. So I'm going to need to bring down my third power and multiply it by the 2 to get 6 times sine of x squared. And then I need to multiply by the derivative of sine of x, which is cosine of x. So overall, I would get 6 sine squared of x times cosine of x over 2 sine cubed of x. I could simplify this to being 3 cosine of x over sine of x. But I think that my math lab would take either form. At least it did when I tried it. Okay, final thing is arcsine and arctangent derivatives. So remember that arcsine of x is sometimes written as sine to the negative 1 of x. It's not the negative 1 power of sine of x. It's just how they denote the inverse sine. And arctangent is written the same way. Tan inverse of x. This negative 1 stands for inverse, not actually to the negative 1 power. And I just want you guys to remember that the derivative with respect to x of arc sine of x is 1 over the square root of 1 minus x squared. And the derivative with respect to x of arc tangent of x is 1 over x squared plus 1. So just write those on your cheat sheet, have them with you for the exam. Let's see here. So I hope that kind of helps you guys prepare. I would say make sure you've looked over at least that, and that you have things that you're worried about forgetting written on a piece of paper that you have right next to you, so you're not having to flip through all of your notes to find it. Yeah, other than that, go in with a good attitude and a willingness to carefully show your work, because I think the number one mistake that's going to be made is people try to do a lot of this in their heads because it's an online exam, and if you do math in your head, you're probably going to make a mistake. And yeah, that's it. Okay.
I will not be lecturing tomorrow, so you guys won't see or hear from me until Friday. Good luck on your guys' exams.